In this session, we're going to talk about rotational motion, solving the tutorial sheet 9 on this topic. So basically, we're going to solve all these, questions, all your questions in your tutorial sheet, okay? Now, as we'll be solving these questions, you can be pausing the video so that you try these questions to just test your understanding and to just familiarize yourself with the concepts. So basically that's what we're going to do. Now, what are just some of the basics that you're supposed to understand? Rotational motion or circular motion, you're just talking about the movement of this object around a circular path, okay? Basically, in linear motion, that is something that we're very much familiar about. Then there's rotational motion, okay? Now, in linear motion, we talked about something like distance or what we call displacement, okay? Now, when you come to rotational motion, this distance or displacement, it is because you are orbiting around a circular path. This distance is an angle, okay? An angle theta, okay? Now, this angle, that you used to measure your distance in meters, okay? However, your angle in this case, you're not going to measure it in degrees. You're going to measure it in what we call radians. Okay. Then in linear motion, you also talked about velocity. Now, when you're coming to rotational motion, this velocity, it is called angular velocity because an angle is made as you are rotating. So this is called angular velocity. However, this one we are going to represent it by a Greek letter, okay? That looks like this. This is omega, a Greek letter. Now, we used to measure our velocity, or we measure our velocity in meters per second, okay? However, the way we're going to measure your angular velocity, it will be, since we are saying an angle is radian, so it's going to be radian or rad per second, okay? Then maybe the last thing that we can talk about is acceleration. Linear acceleration. That acceleration is measured in meters per square second, okay? However, when you come to a rotational or circular motion, we're talking about angular acceleration, okay? Angular acceleration. So you're going to use another Greek letter to represent angular acceleration. This is your alpha, okay? This Greek letter. Now, this one is going to be measured in what? Radians per square seconds. So basically, these are just some of the basics that you're supposed to understand. Other formulas, we're going to talk about them as we start solving questions. So basically, that's it. Now, with me here, I've got question 1. Now, we are told that a horizontally mounted wheel of radius r is initially at rest and then begins to accelerate constantly until it has reached an angular velocity after 5 complete revolutions. Okay, what is the angular acceleration of the wheel? Okay, so what data have we been given? We are told that it begins to accelerate until it has reached, okay, so initially we're told that it is at rest, okay? So what would be your angular speed or velocity in this case? Initially we're saying it is 0. What about your revolutions? Revolutions, we've been told that it is, so revolutions, I'm going to represent it by n. The number of revolution, it is 5, okay? Now, what are we going to do? We're trying to find the angular acceleration. Okay. Now, how are we going to find our angular acceleration? Now, we know that from your linear motions, we used to say, v squared is equals to u squared plus 2as. Okay. Now, when you come to rotational terms, this will be, you know, your angular velocity initial, okay, or final in this case, squared will be equals to the initial one squared plus 2. Now our acceleration, we said it is alpha. Now s is the distance, okay, 2as, not squared though, okay, just 2as like that. Now our s, we're saying it is a distance, and what did we say the distance is? When in rotational terms, we're saying it is theta, or the angle that is being made. So basically we're supposed to find the displacement itself, which is the theta itself, the angle. Okay, now you know that one complete revolution is equals to 2 pi radians, okay, 2 pi rad. Now how are we now going to find, you know, the number in terms of the theta itself? Okay, so we're going to say in this case the theta will be equals to, it is going to be n, the number of revolution that we have, multiplied by 2 pi, okay, multiplied by the radius. Now have we been given the radius? Okay, 5 complete. No, we haven't been given the radius. Okay, so radians, actually 2 pi rad. What am I writing? Okay, so 2 pi n multiplied by 2 pi. So how many revolutions have we made? We are saying 5, so that will be multiplied by 2 pi. Okay, therefore it will be 5 multiplied by 2 pi, that is just 10 pi. So that's what we have as our theta. Okay, now that we have that, is there anything that we can replace? Okay, we just now have to solve for our acceleration, in this case our angular acceleration. So if we're going to make our acceleration the subject of the formula, this one, what are we going to do? Okay, so I'm going to take this one to the other side. So I'm going to remain with 2 alpha. Theta will be equals to the angular velocity final minus the initial one squared. So therefore I'm now going to divide by 2 theta on both sides, okay, on both sides like that. Okay, so the theta, okay, they'll cancel the 2 and the 2, therefore my alpha, or my angular acceleration, will be that. Now have we been given the final one? Okay, the final one, the final velocity, it started from rest. Okay, so what are we going to do? Okay, what do we have as our angular final? So in this case we have not been given, so we're just going to write our final squared minus our initial. Now our initial is 0, so because starting at 0, so I'm just going to write the wf squared, but now multiplied by 2 theta. Now 2, we've already been given that the theta is 10 pi, so I'm going to multiply by 2. Now 10 multiplied by 2, that is 20, so I'm going to have 20 pi. So basically this will be our answer. Okay, basically this will be our answer. We would have solved fully if we were given also the final, you know, angular velocity. So basically that will be your answer for the first question. Now let's solve number 2. We are told that a 250 ball is being swung faster and faster in a horizontal cycle. When the speed reaches 15 meters per second, the tension T in the string is 500 Newton and the string breaks. What is the radius r of the cycle? So basically, if this is the circle, we have, let's say, the radius r, okay, in this direction. Now we also have a tension, okay, in the string. Okay, so this is our tension. We're told that is 500 Newton, okay, and the radius, have we been given the radius? Okay, we're told that this is moving at a speed of 15 meters per second. and we have a 250 is it kg? Okay, 250 kg. I don't know, we haven't been given the units. I don't know if maybe it was a typo, but let's say if it was grams, how are we going to solve it? Okay, let's say it's just like a small ball that is, you know, orbiting around the circle. So what are we going to have? So let's say we have the mass. Now if it is 250 grams, you know that you're supposed to divide that by 1000 to change it to kg, right? So it will be 0.25 kg. Okay, then what about the speed? The speed we've been given that is 15 meters per second. Okay, now the maximum tension before it breaks, we've been also been given it is 500 Newton, like that. Okay, so what are we now going to find? We're now trying to find the radius, r. We don't know what r is. Okay, now what you should understand that is, for uniform circular motion, okay, if it's just moving uniformly like that, it is not changing speed, but let me say at this point, let's say the speed it is 20. At this point it is 20. At every point it's just moving like uniformly, with maybe it's just maintaining the same speed. The tension therefore will provide what we call the centripetal force, okay, as it is moving around the circle. Now the centripetal force itself, okay, the centripetal force, we are saying it to be equals to the tension. Now therefore the tension will be equals to, the way we find the centripetal force, in this case it is mv squared over r. Okay, this is very important for us to understand. Now how are we going to find out r? We just have to make r the subject of the formula. So I'm going to have, if I cross multiply, I'm going to have rt will be equals to mv squared. Therefore I'm just going to divide by t on both sides. Therefore my r is equals to mv squared over my t. Now what is the mass that we've been given? We're saying it is 0.25 kg multiplied by the the velocity. In this case we've been given that it is 15 meters per second, but now this is squared, so I'm going to square it over my tension. Tension I've been given that it is 500 Newton. Okay, basically this is what I have. Now 15 squared, that is like 225. Then the answer multiplied by 0.25, I'm getting 56.25. Now I'm dividing this by a 500. Therefore what would be my radius in this case? So the answer that I have, 56.25 divided by a 500, I'm getting my radius to be 0.1125 meters. So that is what I have as my radius. So the string's length in terms of the radius, so this is the thing, and this is the radius. The string's length in terms of the radius, we say this is the tension, but the radius itself in this case, it is going to be that amount. It is in meters, but now if you want to convert this one to centimeters, it means I'm supposed to multiply by 100. In this case, if I want it in centimeters, it is going to be about 11.3, you know, centimeters. Basically this or this in meters. So that's how we're going to solve the second question. Now let's solve the third question. We're saying if it takes a bike wheel 3 seconds to complete one revolution, what is the wheel's angular velocity? Okay, so we've been given the period. So period, we've been given that it is 3 seconds. Okay, now you know that one revolution, it corresponds to 2 pi radians. Okay, 2 pi radians. Now what are we trying to find? We're trying to find the angular velocity. Okay, angular velocity. Okay, speed is equals to distance over time. We know that speed is equals to distance over time. You know that, okay? So because velocity is a change in, speed. So in this case, if we are going to use this basic definition, just make you understand that we're trying to find the distance, okay? The distance first then divided by time. We've already been given the time, it is 3 seconds. So basically we're just supposed to find first what the distance is in this case. So now we're saying the distance, we're saying it is an angle, okay? And it's measured in radians. So basically that's what we're going to do. Now we know that 1 full revolution corresponds to an angular displacement of 2 pi radians. Now your angular velocity in this case is going to be per unit time, and we know that. So in this case we're going to have our angular velocity as equals to, since we have a full revolution of that, and that will be the distance, so we're going to have 2 pi radians divided by 3 seconds, okay? Basically that's what we are going to have. I'm going to put my radians here, okay? So 2 pi, I'm dividing it by 3, so I'm getting 2.094 radian per second. So basically this will be our angular velocity, okay? Now that we found that, let's go to question number 4. Now on question number 4, we are told that a solid bowling ball of mass 6 kg and radius 0.15 meters is traveling at a linear velocity of 4 meters per second. What is the angular momentum of the ball? Okay, this is a very interesting question. So we're trying to find the angular momentum of this ball. Okay, so what have we been given? Mass, we've been given that this is a 6 kg ball. Then what are we been given? We've been given the radius. The radius, we're saying it is 0.15 meters. Then what other thing have we been given? We've also been given the speed in this case. Now we've been given linear velocity. It is for a certain purpose. We are going to realize why we've been given linear velocity. In this case it is 4 meters per second, okay? Then what other thing do we have? Basically this is what we have. So let's say this is the ball, okay, and it is going in this direction, okay? Basically it's going to be moving like that, and it's going to be rotating, and the mass we are saying it is 60 kg. The radius we say they've been given 0.15, okay, and the velocity at which this ball is moving, we are saying it is 4 meters per second, okay? So as it is moving, something interesting is going to be happening, okay? Now what are we going to do? We're trying to find the angular momentum. Now the way we find our angular momentum is given by the angular velocity multiplied by the moment of inertia, which is I. So basically we're supposed to find what the angular velocity is and the moment of inertia for us to find the angular momentum. So what are we going to do? Let's start with the moment of inertia, which is I. Now the moment of inertia will be equals to 2/5, okay? 2/5 of m r squared, okay? Basically that will be your moment of inertia. Now we're going to say 2/5 multiplied by the mass. We've been given that it is 6 kg. This will be multiplied by, okay, let me also put the units in this case, kg multiplied by the radius. The radius we've been told that is 0.15 meters. Now this is squared. So now we're just supposed to solve this, okay? So we've got 2/5 multiplied by 6 multiplied by 0.15 meters squared. 0.15 squared, that is giving me 0.0225, okay? Now that I've got this, now let me just multiply everything. my answer that I have multiplied by 6 multiplied by 2 divided by 5. I'm getting my moment of inertia as 0.054. Now we said that the 6 is in kg, so I'm going to put kg meter squared. Okay, basically this is what I'm going to have. Now it was meters here, I've squared it because there was a square outside. Okay, that's why I've squared the last one. Now that is our moment of inertia. What about now our angular angular velocity? Now we said our angular velocity, in this case it is v over r. Okay, if that is what we have, what do we now do? So we put v over r because this one it is rolling without slipping. Okay, a barreling ball. Okay, so what are we going to have? We've been given the velocity of 4 meters per second divided by, this is 4 meters per second, divided by the radius. Have we been given the radius 0.15 meters? Okay, so basically this is what we have. So now when we solve, what are we going to have? 4 divided by 0.15 meters, I'm getting 26.67 radian per second. Okay, basically this is what I'm going to have as my angular velocity. Now that we have everything, we can now find the angular momentum. Now we said that angular momentum will be equals to our angular velocity multiplied by a moment of inertia. Now angular velocity, or just from finding 26.67 radian per second, this is multiplying by okay, let me just write it nicely. Radian per second multiplied by the moment of inertia. Okay, 0.054 kg meter per second, meter squared actually, not what I'm talking about. Okay, now that we've got this, what do we now have? Okay, so let's now calculate. So I'm multiplying 0.054 multiplied by 26.67. So I'm getting 1.44. Okay, so this will be kg meter squared. Then because there is your second is down, so I'm going to say per second. So basically this will be your angular momentum, and these are the units. So basically that's how you solve question number 4. So the ball's angular momentum about its center is about this. Okay, so now let's go to number 5. Now we're saying a ball of mass 4 kg and radius r is equals to 0.12 meters is traveling down a slope with a vertical height change of 12 meters. If the ball starts from rest, what is the final linear velocity of the ball as it reaches the bottom of the slope? Neglect air resistance. Okay, so what information have we been given? We've been given the mass. We're saying that it is 4 kg. We've been given the radius. We're saying it is 0.12 meters. Then it was dropped at the height. The height we've been given, this is a vertical height of 12 meters. Okay, what other thing have we been given? We've been also been told that it started from rest. Okay, if the ball starts from rest, okay, if it starts from rest, what will be your velocity initial? So your v initial will be 0. Okay, Now it is rolling without sleeping. Okay, so what are we going to have now? If this is a ball of mass, so we're going to assume that it is a solid sphere like that. It is a very solid sphere. So we can also put the moment of inertia, and we said the moment of inertia is 2/5 of mr squared. Okay, basically this is what we have. Okay, now this ball is traveling down a slope. Okay, so if we say this is a slope and this ball is traveling down a slope, okay, initially you're going to see that this ball at the top is going to have potential energy as it is moving and as it is rotating. Okay, that's why I'm putting the aspect of inertia here. As it is rotating, the potential energy is going to be converted, okay, to translational energy, because it is rotating now. Now as it is rotating and it is moving, now you're going to have also kinetic kinetic energy. Now this is rotational kinetic energy. It is moving but it is also rotating. Okay, so basically this is what we're going to have. Therefore all your potential energy that you had, because it was at a height of 12 meters, it is going to be converted to your kinetic energy. So basically we have to understand that before we start solving this question. So we're trying to find the velocity. So let's start. We are saying all our potential energy okay, initially it had potential energy. You're going to have, as it starts moving, you're going to have your kinetic energy, okay, plus you're also going to have your rotational kinetic energy. Okay, now your rotational kinetic energy is found by half of the moment of inertia. Now your v squared, in this case it is okay, let me just write my rotational kinetic energy here, r, before I put k e, that is rotational kinetic energy. Now let me put the formulas, okay, because it has potential energy initially and energy is conserved. Okay, so because if they've told us we have to neglect air resistance, so the energy that you started with is going to be the energy that you're going to end with. So initially at rest it had potential energy, now it started moving, it had kinetic energy, and in as much as it was moving, it was also rotating because it is a ball. So basically those are the energies that you're going to have. Now what is the potential energy in this case? You know that potential energy is measured in m, is mgh. Okay, your weight in a certain, with a certain height. Okay, now your kinetic energy, you know that it is half mv squared plus, now because you have the rotational kinetic energy, it is also going to be half, but in this case is your mass. In this case it will be according to your moment of inertia multiplied by your angular velocity, like that. So basically this is the formula that we have. So we just have to now let's say solve this. Okay, so now if I replace some of the things here, what am I going to have? I'm going to have mgh is equals to half m v squared plus half. Now we said our moment of inertia is equals to that, so I'm going to replace there. So when I replace here, I'm going to have 2 over 5 mr squared. Okay, then when I'm also replace here for your angular velocity, we said angular velocity, we are saying it is we said that is v over r. Okay, now if it is v over r, I'm going to also replace, so I'm going to have v over r, but don't forget it is squared. Okay, therefore if it is squared, it means I'm just squaring my v and I'm also squaring my r, like that. Okay, it is the same. Okay, so now if I'm going to solve this, what am I going to now have? Okay, so let me first solve this part. Okay, I see what I have. So what do we have? Have v squared over r squared. Okay, so what do we have? Okay, I'm trying to look at the data. Initially we've been given that v we've been given is 0 initially. Okay, so what do we have? Okay, so let me first solve the one for which one should I start with? Okay, let me solve this part like I said. So in this case I'm going to first since these ones are multiplying, my r and the r squared can divide. Okay, now if they divide, what do I now have? This side I'm going to have my half mv squared plus. Okay, now what other thing do I have? The 2 and the 2 can divide, therefore I'm just going to remain with 1 over 5. Don't forget we remain with an m and we remain with v squared. Okay, so that is what I have. Now here where I've reached, I can cancel out m or I can factorize out m. Okay, and what am I going to have? Okay, let me first factorize mv squared because it is the same on both sides. Then I solve the numbers themselves. I'm going to have 1 2 plus 1 1 over 5 1 over 2 plus 1 over 5. Then I'm going to have mv squared like that. Now if I solve what is in the bracket, the common denominator, it will be a 10, right? 2 into 10, that is a 5. 5 multiplied by 1, that is a 5 plus. Okay, is it? Yeah, it is. Then I've got 2 into 10, that is 5. 5 multiplied by 1, that is a 5. Then again 5 into 10, that is a 2. 2 multiplied by 1 on top, that is a 2. Okay, then I have my mv squared. Allow me to rub on top. Okay, so we have 5 plus 2, that is a 7 over 10. Then I have mv squared. Okay, so basically this is what I have. Okay, okay, basically this is what I have. Now what do I have? We said potential energy, this is equals to the potential energy on the other side. Okay, initially it had potential energy, and we said our potential energy is mgh. So allow me to write my mgh. Now that I've got this, I can cancel my mass on this side and my mass on the other side. Now that I've got this, what do I now have? I'm just supposed now to make v the subject of the formula. For me to make this the subject of the formula, I'm going to this side multiply by 10 over 7 and also the other side 10 over 7. Now when I do that, the 7 and the 7 will cancel, the 10 and the 10 will cancel. I'm going to remain with v squared will be equals to gh multiplied by 10, that will be 10. Okay, let me just put the 10 over 7 in front. 10 over 7, then I've got gh. Okay, now that we got this, I'm just supposed to find the square root of that. Okay, for me to find my v. Okay, so v in this case will be equals to the square root of 10 over 7 gh. Okay, so now if we solve that, what do we have? Okay, now the acceleration due to gravity, I'm going to take a 9.8. okay, you can choose the one if you want to use 10, but I'm going to choose 9.8. okay, so I'm multiplying, I'm finding the square root of 10 over 7 multiplied by 9.8. Then the height we've been given that it is 12 meters, so multiply by 12. Okay, so when I solve, 10 multiplied by 9.8, that is a 98, multiplied by 12 divided by 7. Okay, so I'm finding the square root of in the bracket I have 168. So that is what I'm going to have. Now that I've got this, I'm going to find the square root of that. The square root of 168, I'm finding 12.96. Now this is a velocity, it's going to be meters per second. So basically this is how you solve question number 5. Let's now solve question number 6. Now we are told that a ball is attached to a string that is 1.5 meters long. Okay, I'm just going to put a meter here. Probably it was a typo or whatever, but for the sake of solving, I'm going to put a meter there. It is spun so that it completes 2 full rotations every second. What is the centripetal acceleration felt by the ball? So let's say this is the middle center and like that, and this ball is moving there. We've been given that it is attached to a string. Let's say this string is 1.5 meters. Okay, so it is going to be rotating as it is moving, so this will be revolutions per second, like that. Okay, so we are told 2 full revolutions per rotation. Okay, full rotations every second, so I'm going to say 2 revolutions per second. Now it is moving and they're asking us to find, as it is moving, let's say it has reached here and it is accelerating, they're asking us to find the centripetal acceleration. Now the centripetal acceleration is due to what we call the centripetal force. Now the centripetal force is on the middle. It is always pushing, keeping the object to be moving around a circular path, and as it is keeping that, that object is also accelerating. That acceleration is what we call centripetal acceleration. So basically this is what we've been given. So how are we now going to solve? Okay, so we've been given the radius 1.5. Let's say it was 1.5 meters. Okay, then the rotational rate, we are saying the rate at which it is rotating. Okay, or let's say the frequency in this case, how frequent it is rotating. We're saying it is 2 rotations per second. Okay, now we have to now calculate the angular acceleration, okay, or the centripetal acceleration. And the way you find your centripetal acceleration is equals to your angular velocity multiplied by r. This is the formula for the centripetal acceleration. So basically it means we're supposed to find what the angular velocity is for us to be able to solve this question. So basically, how are we going to find the angular velocity? In this case, you know that we're saying distance over time, right? It's like the speed, right? Or like the velocity. So the distance, we said, I'm writing distance over time just to make you understand. Okay, the distance is, we said it is the theta, the angle, and the time you've been given. Okay, so what are you going to do? Okay, so in this case, therefore, our angular velocity will be equals to, the distance is going to be 2 pi, right? 2 pi radians, right? That would be the distance. But now there's a how many revolutions has it made also? So you have to also multiply it by the frequency, how far it was moving at 2, right? So you're going to multiply 2 pi radians multiplied by the frequency. Okay, now in this case, the frequency, we've been given that it is 2 hertz. Okay, you know that 2 hertz, it is just it was moving 2 revolutions per second. Okay, 2 full rotations every second. So this is 2 over second. Okay, 2 over second. So basically this is what you have. So you just have to now solve. Okay, now if I multiply 2 pi multiplied by 2, what do I have? I've got 4 pi rad, okay, over second. Okay, now 4 multiplied by pi, what do I have? I'm getting 12.57. This will be radian per second. So we found our angular velocity. So now that I found our angular velocity, we just have to now replace and solve. So if we were to solve this one, our angular velocity 12.57, okay, radian per second, this is squared multiplied by the radius, which is 1.5 meters. So how are we going to solve this one? Okay, now that we've got this, okay, so we are just multiplying. Okay, 12.457, which I already have on my calculator. I'm multiplying it by 1.5. Okay, oh, not really. I have a square here, so I have to make sure that, so I have to first square 12.5. So 12.57 squared, I'm getting 158. Okay, we're multiplying this by 1.5. So the answer that I have multiplied by 1.5, I'm getting 237. So this will be meters per square seconds. Okay, so basically this will be the acceleration for this object. In this case, we're talking about the centripetal acceleration. Okay, now let's solve question number 7. Now we're told that candy companies have long strived to catch the attention of children. One item that does this particularly well is the gumball machine. A certain gumball machine has a column that is 1.5 meters tall with a spiral track of radius 0.25 meters on which the gumball on which the gumball travels. The slope of the track is 10 degrees and the average frictional force exerted on the gumball as it travels down the track is 0.05 Newton. What is the centripetal force on a gumball of mass 0.1 kg as it reaches the end of the track? Now, we just have to visualize what they're talking about here. Let's say if this is the ground where this, this spiral, let's say this machine is, okay? Since they're talking about something that is spiral, let's say it is like this, okay? Let's say this is a gumball machine, okay? Okay, now we've been told that in terms of meters, how high, they're saying the column is 1.5 meters tall, okay? So this is 1.5 meters. Now we're saying with a spiral track, okay, spiral, let me say this is our spiral track. It's just going like that, you know, going like that, it's going like that, and it's going like that, and probably when you put it goes out like that. If this is our spiral track inside, okay, let's say it's inside like that and it's going like that, it's a machine, okay? Now we've been told that this spiral track, it has a radius actually of 0.25 meters on which the gumball travels, okay? And the slope of the track is 10 degrees. Okay, we have a 10 degrees here. We have to note that. And the average frictional force exerted on the gumball as it travels is 0.05. Okay, the frictional force exerted on the gumball. Okay, so we've also been given the frictional force of 0.05 newtons. So basically we're now trying to find the centripetal force on the gamble of the mass of 0.1 kg as it reaches the end of the track. Let's say you've put it here and it has gone, it has experienced some friction. Okay, after it has moved all this way, okay, it's going to come out from this far end. So now what will be the force at which this one is going to come out? Basically, this is just my visualization. So when you visualize, now it will be very easy for you to solve. So the length of the track, okay, so the length in this case it will be the height. Now the height we've been given that is 1.5. however, also been given the sign itself. Okay, we've been given the what's this, we've been given the we've been given the what, we've been given an angle, so we have to consider that angle, and that is very, very important for us to understand. Okay, so how can we make the length? Okay, now I'm trying to also incorporate the slope of the track on an average frictional force as it travels. Okay, the slope, let's say if this is a slope, okay, and we are trying to find if this is the length, and we have an angle that it has made. Let's say this is our 10 degrees. Okay, now if this is the same length which we are calling as h, how are we going to find our length? Okay, and we have been told that this is 1.5, 5 meters tall. Okay, son. Okay, so what are we going to do? So basically this is what we have. So we're going to use our soccer tool. Okay, so we're going to say now our sine theta will be equals to opposite over hypotenuse. Okay, now our opposite in this case is the h over the hypotenuse. Okay, in this case there's no hypotenuse, let's just say it's 1. Okay, let's say our hypotenuse, and we make the h the subject, so h in this case will be equals to we're going to have what, the height. What have I written? Okay, h in this case is going to be, actually the height we've been given, it is 1.5. Okay, so 1.5, so it's going to be the height, the total height in this case is going to be because we've been given an angle, is you are going to have sine theta, so to be sine theta, okay, multiplied by the hypotenuse. Okay, in this case let's say this is our hypotenuse. Okay, therefore how are we now going to find our hypotenuse? So in this case it means our hypotenuse will just be the height divided by sine theta. Okay, because we've been given the height, we've been given the sine theta, but we haven't been given the hypotenuse, which is what I'm trying to find. So therefore I've now known how we're going to find our height. Okay, now this is the length. I'm trying to find the length, actually not really like the height. The hypotenuse, if this is the thing we've been given, if this is a track, okay, and it's spiral like that, let's say there was some slope that they're talking about. If there was a slope and it's something like this, I'm trying to find this distance from here to there, okay, which is the length of the track. But we've been given the height, we've been given the angle, therefore I'm trying to find this track length. Okay, it's going to apply somewhere, I think. So our track length is going to be the height divided by sine theta. Okay, in this case sine 10. Okay, because we have 10. The height, we are saying it is 1.5. This will be divided by sine 10. Let me just do sine 10 degrees on my calculator. Sine 10, I'm getting 0.1736. Okay, now that I've got this, I'm dividing into 1.5. So 1.5 meters divided by 0.173 meters, 0.173, I'm getting 80.64 meters. Okay, this is the track length. Okay, track length. Okay, we found the track length. Very, very important. Now, what are we now supposed to find? Okay, what about, because this thing is coming down, there's going to be some potential energy. Let's also find the potential energy, or the gravitational potential energy in this case. So mgh, which is our potential energy, right? I'm going to have the mass. My mass, we've been given the mass of I've been given the mass. Okay, the mass, we are saying it's 0.1 kg. Multiplying by acceleration due to gravity, I'm going to take 9.8 multiplied by the height. Now the height we're using is 1.5, not the track length. Okay, 0.1 multiplied by 9.8 multiplied by 1.5, I'm finding 1.47. this is a potential energy, so it is in joules. Okay, basically before it started moving, okay, it has potential energy. Then when it starts moving, it's going to gain kinetic energy. Okay, now in this case we're going to have our kinetic energy. Now the kinetic energy is going to be at the bottom. So this is a potential energy initially when it was on top, and when it spiral, when it reaches outside, that's when it's going to have the kinetic energy. So this will be the kinetic energy at the bottom. Okay, so let's find the kinetic energy at the bottom. So what am I going to have as my kinetic energy? Okay, so for me to find the total energy, I also have to find the friction. Okay, because there's some friction, okay, that was lost as it was moving. Okay, so from there, because if initially this was the potential energy that it had as 1.47 joules, when it reaches down here, all the potential energy is going to be converted to kinetic energy, which should be 1.4, and this is the answer that we're supposed to write. However, we also had friction. Okay, that was lost, energy that was lost due to friction, so we have to find the friction. So kinetic energy, we've said it is 1.47 as well, 1.4 joules. Okay, so we're supposed to subtract the friction that it experienced. So now what will be the work done by friction? Okay, so what are we going to have? Okay, so what do we have? Have we been given the frictional force? Let's see. And a track gamble, frictional force exerted is 0.05. Okay, so I've been given 0.05. okay, multiplied by, you know that work done is equals to force multiplied by the distance, right? Okay, that's why I'm okay, so yeah, work is force multiplied by the distance. Now we found the frictional force. They've already given us actually multiplied by the distance. Okay, now the distance that we are going to write here is when it reaches the ground. Okay, because that's where the kinetic energy is going to be found, and that distance we're talking about is what? The track length that we just found initially. Okay, as it was moving all that track. Okay, this is the track length that we're talking about. Yeah, actually I'm mixing things. So this is the track length, and we found this whole distance is the one that we want, and that is the track length, and it's the one that we had found initially when we were solving. So I'm going to write 8.64, which is the track length, or the length as that ball was moving. Okay, now 0.05 multiplied by 8.64, what do I have? I have 0.432 joule. Okay, now this is what I have in terms of work done by friction. So it just means I'm supposed to now subtract it from the kinetic energy that I have. Okay, so we lost 0.432 joules of energy. So therefore, what will be my final kinetic energy at the bottom now? So 1.4 minus 0.432, I'm getting 1.038 joule. Okay, this is what I have in terms of the kinetic energy. Okay, basically now this will help you now to find the velocity. Okay, it will help us to find us the velocity, because we're trying to find the centripetal force, and we've said centripetal force is F is equals to M, V squared divided by R. So we're trying to find this V squared. Okay, everything we have now, we have that as our kinetic energy. And how do we find kinetic energy? You know that kinetic energy is half mv squared, right? So kinetic energy is equals to half mv squared. Okay, basically this is what I have. I'm just now supposed to make v squared the subject of the formula. Okay, in this case I'm going to divide by mass on both sides. The mass are going to cancel, then I'm going to multiply by 2 on both sides again. The 2 and the 2 are going to divide, therefore I'm just going to remain with v squared on the other side. So basically this is what I have. I have v squared will be equals to 2 multiplied by ke over m. Okay, for me to find my v, I'm going to square root on both sides. So v will be equals to 2 multiplied by the kinetic energy. We've already found that it is that. So this is 1.038 joules. Okay, divided by the mass. The mass, what have we been given as the mass? 0.1 kg. We are square rooting this. Okay, so what is the v in this case? Okay, so what do I have? 2 multiplied by 2 multiplied by 1.038 divided by 0.1. I'm getting the square root of 20.76. Then I'm supposed to find the square root of 20.76. Okay, so therefore my v in this case, I'm getting the square root of 20.76. I'm getting 4.56 meters per second. Okay, this is what I have as my v. Therefore now I'm just supposed now to solve to find as the force. So I'm saying the centripetal force in this case will be equals to the mass we've been given is 0.1 kg multiplied by the velocity that we're just from finding, 4.56 meters per second, multiplied divided by, okay, don't forget that this is squared, divided by r. R is the radius we've been given to 0.25 meters. Okay, basically this is what I have. Okay, now if I solve what is on top, 4.56 squared, okay, that is giving me 20.8. 20.8 multiplied by 0.1, I'm getting 2.08. This is divided by 0.25, and what do I have? 2.08. I already have it. I'm just dividing by 0.25. I'm going to get my centripetal force as 8.32 Newton. Basically this is how you solve question number 7. Okay, a very long question indeed. Then let's solve question number 8. Now we are told that a 25 kg student is riding a merry-go-round with a radius of 5 meters. What is the centripetal force on the boy if his velocity is 6 meters per second. Okay, let's just analyze. Let's say this is a merry-go-round, okay, and let's say it is standing on this surface. Okay, so we are told this is a child. Okay, let's say this is a child and it's sitting nicely like that. Okay, now if it's sitting, the radius we've been told that is 5 meters. Then as it is moving at a velocity of 6 meters per second. So basically this is just what we are analyzing. Now what do we have? We have the mass as 25 kg. We have the radius, okay, of rotation as 5 meters. We have the speed, okay. In this case we're talking about the tangential speed. Speed in this case, or speed, the velocity, it is 6 meters per second. Okay, so what are we going to do for us to find the centripetal force? And we said the centripetal force, it is mv squared over r. Okay, we have the mass of 25 multiplied by the velocity of 5, velocity of 6. Now 6, when I square 6, is just 36, divided by the r, which is the radius, which is 5 meters. Okay, now 25 multiplied by 36, 25 multiplied by 36, I'm getting 900. 900 divided by 5. Okay, now 5 into like 9, that is 1. 5 into 10, that 5 into like 40, that is 8. I'm going to have 180 Newton. So this will be the centripetal force as this, you know, she's going on this merry-go-round. Okay, so that is very important for us to know. Now let's solve question number 9. We're told that a car of mass m is driving around a circular track of radius r at a constant velocity of v. The centripetal force acting on the car is Fc. Okay, if the car's velocity is doubled, what is the new centripetal force required for the car to drive in the circular path? Okay, this is a very interesting question. So what did we say? If you now double the centripetal force, what are you going to have? Mind you, we said centripetal force just pulls objects towards the center. We said the centripetal force is equals to mv squared over r. Okay, if this is what we have now, if we are going to double, we've been told that around the centripetal force acting on the car, if the car's velocity is doubled, so we're doubling the velocity. The velocity initially is v, but now if you double it, it means now we multiply it by 2. Okay, so what are we going to have? So in our equation, we're just going to wherever there is mv, we're going to put now 2 multiplied by v. So I'm going to have m. In this case, I'm going to put, where there's v, I'm going to put 2 multiplied by v, that is squared, okay, over r. Okay, now that I've got this, I can now solve what is in the bracket. Now 2 multiplied by this is squared. The square falls on 2. It also falls on v. Okay, now when it falls on 2, that will be a 4, right? So I'll have a 4 v squared, right, over r. Okay, now if I now bring the 4 multiplied by the m, I'm just going everything bracket multiplied by m, I'm going to have 4 m v squared over r. Basically this is what we are going to have. That is our final answer. However, look at something here. This mv squared over r is also this mv squared over r, and this is equals to that. So I can replace where there is mv squared over r, I'm going to put fc. Okay, so it's going to be now finally 4 multiplied by fc. So it means that what this means is that the new centripetal force required is 4 times the original one. Okay, it is 4 times the original one when you double the velocity. That's what that just means. Okay, now let's solve the last question. question number 10. We're told that the passengers in a car driving over a hill at a speed of 5 meters per second feels weightless. Oh. Calculate the radius of the curvature of the hill. Okay. So what are we finding first? We are finding the radius of the curvature of a hill. Okay, so what first do we have? We're saying we have to note everything that they're telling us. They're telling us they feel weightless. So if they have no weight, you know that weight is equals to mg. If they have no weight, meaning it's 0, right? And weight is also equals to your normal force, right? So it means the normal force also, the opposite, the force that will be acting the opposite will also be 0. Okay, so that is what happening. Okay, now what you should understand is that only gravity is the one that is going to be providing the force that is needed to keep this this object at that curvature. Okay, so what are we now going to have? Okay, now we know that we find the centripetal force as m, we've been talking about this, mv squared over r. Okay, and we're trying to find the radius. Okay, now the passenger in a car driving over a hill on a speed at a speed of that, calculate the radius of the curvature of the hill. Okay, if let's say this is a curvature and it's going, okay, we're trying to find the radius. Okay, basically as this car is moving, what will be pulling it towards the center? It is the centripetal force. Okay, and now the centripetal force is going to be provided by what? By the weight of this object. Okay, so the weight is the one that is going to be providing the centripetal force. Okay, because they haven't given us a centripetal force. So in this case, where the centripetal force, I'm going to put mg, or the weight. Okay, in this case is multiplying by mv squared over r. Okay, now that I've got this, I can cancel out m on both sides. Okay, now I've remained with g is equals to v squared over r. Okay, now that I've got that, what do? I just make r a substitute of the formula, which is the one that we are finding. So it's going to be v squared over g. Okay, now what is our v? Our v, we've been given that it is moving at a speed of 15 meters per second. This I'm going to square it, multiplied by our acceleration due to gravity, which is about 9.8. I'm going to use 9.8, although others use 10. Okay, it's still fine. So 15 squared, what do I have? I'm finding 225 over 9.8. Okay, so the 225 that I already have on my calculator, I'm dividing it by 9.8. So what do I have? I'm getting 2.96 meters, 22.96 meters. Okay, so if you want, you can round it off to a very nice number. I can round it off to the nearest. I can say it's 23 meters. So the hill's radius of the curvature must be about 25 meters for the passengers to feel weightless. Okay, for them to feel like, okay, we don't have weight. Okay, basically this is how you solve these questions. So don't forget to also subscribe to our channel. Thank you. See you in the other sessions.